there's method to madness, and full stop, safety. Support Coco Touch, work side by side with Objective-C. That might be of interest to you, so it would be great if you can start a new project and go project new Swift, that's it. But most of you probably work with large scale or middle scale legacy code bases. I've been looking at this for a while, and yeah, it's kind of fun. Like it works seamlessly, and sometimes even if you get stuck with Swift, you might say, no, fuck this, I'll do an Objective-C, and it plugs in perfectly. Single implementation file, node.m.h, and some bells and whistles, error handling, closures, multiple return values, functional programming, etc., etc. They've been working on this for a while. They probably looked at stuff like Ruby, Go, JavaScript, Erlang. They mixed and matched and they came up with Swift. All right, there's the hello world and Objective-C. 1, 2, 3, 5 lines. There it is in Swift. Nice and easy. Alrighty, so the first thing you want to do in a language is declare variables. And I've highlighted the language, keyword, or native types, and the rest is my own stuff. So how do you create a variable? Keyword var, your name, colon, type, and the value what you want to give. And that's mutable because it has the word var in front. If you want to declare a constant, use let. So a couple of style pointers here. You're pretty much always going to be using let as your default way of declaring a variable. And use a var every time that you think you might change something. For example, so we saw here, that's how you declare a variable, a string for example, or an int. You don't have to do that. It's smart enough to infer a type, so var version equals 3, int, let meetup city equals Athens. Booleans, you can use Unicode and emojis, both as values of course, but also as declarations. I think you've got to be a real asshole to do that, in my opinion. Alrighty, so that's cool. That's easy. Variable, name, type, and value. For style, always use let as your default. Fall back on var if you want to change it down the line. Type aliases. So it's not a big deal, this one, but you know, it made its way into the talk. It's like the type def keyword in C, but easier. A very specific way of assigning a native data type to the alias you want to make. And here's a nice example. So you're working with sound, you want to work with amplitude, you don't want to use the native type, you want your code to be readable. So you type alias it and assign it the minimum value of unsigned int 16. So this is pretty cool. Bear with me here, that's a tuple. With type alias, you can assign a tuple to a type if that's too complicated for you. And here we can see the method overloading, which is illegal Objective-C in Swift. Pretty much do the same thing, but instead of having to pass a parameter list, you can assign a position to it like that. One of the, everybody works with strings, so very easy to declare them. They're inferred thus. You can add a string to a string. This is the format string in Swift. So Objective-C formats things are really ugly. In Swift, that's all it is. It's like slash, parentheses, and your value in there. Collections, everybody uses collections every day. And that's how you declare them. square brackets, and a list of your elements within. Type inference, these all are the same thing. More modern syntax, brackets and string, or you can use generics and have names as an array with string. Other collections, dictionary. People with iOS, you know, that you use stuff every day using dictionaries and arrays all the time. And as a side note, I don't know who's been working with Objective-C long enough. Remember when they didn't have these and it was like, and it's dictionary with objects and arrays. So that's very, you know, fresh. You guys working with other more modern languages, it's a you know, big deal. Objective-C program is, you know, pretty cool. Loops, self-explanatory. The only thing that's worthwhile mentioning here is that while you can put parentheses, but nobody uses those, and you always need brackets. You can't have like a single line, and you can get a compiler error. And here's a syntactic sugar here for number in a range. Range, initial value, 3 dots, final value. Okay, not too advanced, but you know, some cool stuff you can do with Swift. So that's a dictionary, and that's a tuple. We'll see what tuples are in a second. And it's smart enough to be able to map these types into these types in the tuple, and you iterate and you print them. Some array functionality here. A list of items. You can add an item. It's mutable, remember, so you can do that. You can add a bunch of items, or you can add an item to a specific index. Same with dictionaries here. The subscript operator for the dictionary works fine with the key. It's a variable, therefore you can assign a value to that key. If it doesn't exist, it's nil. Why? Because it's an option. We'll see that in a second. Options. Entirely new concept in Swift. Objective-C. Can I take a second and ask you, who's working on Swift at the moment? Okay. Project New Swift or legacy code base in Swift? Oh, okay, cool. What do you think about options when you first saw them?
They were tragic because there were a lot of bugs in Swift.
All right, so version 1.
Yes, since they fixed them, they're okay.
All right, cool. So, you know, an optional, it says there's a value and it equals X, or there isn't a value at all, only, and that's it. The concept, you know, some Objective-C stuff, the concept of optionals doesn't exist in Objective-C, yeah? The closest thing is the nil keyword, but as you know, the nil keyword only applies to NS object, inherited objects, not to native primitive types. In Swift, anything can be an option. And as a matter of fact, it's worth mentioning here that Swift doesn't have primitive native types. Everything is the object ID or whatever you call it. So you can work with every single type there is. Like it says on the 3rd bullet point. Alrighty. So let's say you declare an option. You put a little question mark next to the type of the variable you're declaring. If you don't do it, the compiler might complain on you, and that's where safety comes in. It forces you to use these things. And as a matter of fact, I'll go as far away to say that in Swift, if you compile, you're half the way there. In Objective-C, that doesn't mean anything if you compose. For example, so you work with view controllers, iOS guys, and you have your touches begun, and the set comes in, and that's a set of UI touches, for example. And the only reason you know it's UI touches is because you have a contract with the API that says, look, man, touches began, it brings you a set, and these have UI touches in it. Whereas in Swift, it's going to say, touches began, you get not actually a set, an array. And these objects are UI touches no matter what. And if you try to work with them with a different data type, you get a compiler error, which doesn't happen in Objective-C. So if you're working with Swift a bit, you might find yourself going back to Objective-C and hating it a bit, or thinking, oh my god, this is broken. Well, which is fair enough, but maybe then you start thinking, okay, maybe I can write Objective-C better, or maybe I give up 100% and work on Swift. It's all good. You're not actually supposed to do this. With an optional, and only with an optional, you can check if the value is nil. Regular data types that don't have optional, that aren't optional, will give you an error again. You say, no, it's not an optional. This is actually taken from Swift 1.0, prior to optional binding. You say if Vedas is nil, do nothing or return, else assign that variable to Vedas with an exclamation mark. And that's how you unwrap an optional. And apparently you're not supposed to do that much. What you can do is use optional binding. So same stuff here, dictionaries, optionals. What you do here is you say if let Veda equals cast Veda. Now that's nil, you don't enter the if loop. If it has a value, so which is the other property that optionals have, you enter the if statement, and you can use Veda regularly without having the exclamation mark. So that's the way of choice to use optionals. I thought I might add the guard keyboard here. That's how you manage control flow. It's stylistic, so you could have easily said if this, do that, else return. But with guard, usually you see it at the top of a block or some code, and it says guard expression to be evaluated. If it's not nil, continue, else do something here, return. So I don't know about you guys, I saw a lot of that when I was playing around with Swift, getting runtime errors while trying to access a non-existent variable for some method. If statements, self-explanatory, some style here. You can use parentheses or not. You'll never see them anymore. Tuples. So they're pretty cool. You've probably seen them a dozen times in other languages. They're new here. They group multiple values into a single compound value. Can be any type and don't have to be the same type in each other. So here's an example taken straight from the docs. Let error equals tuple 404 status code and not found. When to use this thing? So sometimes you don't have two variables, but you don't want to declare an object. So you want something more formal, like a tuple, that works in limited scope. And that's where these come in. You can assign them thus. We saw that before with the dictionary stuff. You can print them. You can name them. And once you name them, you can access them with the dot operator. So a lot of fun stuff you can do with these sort of things. Share data structure without sharing code with tuples. So that's pretty interesting. Example. I have a third-party library that returns a tuple. And I don't have to declare at the top of my code or include in my code. I know it returns a tuple, and all I can do is saying that my code is ready to receive a tuple returned by this third-party library. I've never heard of in my life, and it seems to match, and it works flawlessly. I'm not actually done this, but I was working to play around with it. It's not really pro tip. Switch statements, nothing spectacular here. Let's look at the cases. Case 1, case 2, 3, 4, case 3 dots operator, case array. No break statements required. It doesn't fall through. Whereas in Objective-C, if you don't put the break statement, it will fall through. Or C for that matter. And you can use it on objects. So send as a text field and or my button. And so some calling environment sends you an object, depending on what the case is. We'll show it. Functions. Use the func keyword. Very simple function, prints hello world. Alright, let's look at some more comprehensive stuff for functions. So how do these functions work? You always have to have the func keyword. And like in any language, you have a parameter list, yeah? And a return value. And some languages allow you to use default arguments too. And in this case, we're using all three of them. So hello world, named parameter, string, equals John. Print hello world name. So if you call hello world like that, it only prints John. Exactly, no, not exactly, similar to before, we're not returning nothing now. We're returning a string, and that's how you do a return value in Swift. You have the arrow and your return value. So if you go back to this one, that could be an arrow and parentheses for void. And, you know, let a strings, hello world, nothing surprising there. Alright, closures. Self-contained blocks, a functionality that can be passed around using your code. And so this is pretty interesting. So if you assume that maybe these people, you know, were working this language for the past few years, and at some point in Objective-C, they said, okay, here's a concept of blocks. I get the feeling that maybe they were saying, let's prepare these people for these things called blocks. So when we throw a new language out in the wild, people are familiar with these things. And as a matter of fact, functions are closures with syntactic sugar. So everything in Swift, you know, scope is a closure. That's the following form. That's the syntax. Parameters, arrow, return type, in, and everything between in and curly bracket at the bottom is the stuff in the closure. So let's have a look at a couple of examples. Let hello sayer. So let hello sayer constant. Declare it as a closure. Takes nothing as a parameter. Returns nothing. In print hello world. If you haven't seen this before, it might take a while for you to get your head around it, but it becomes second nature very quickly. You can have a function do task that takes that as a parameter, name parameter, if type that, do task, alright, classes. Every modern language has classes. Swift has no universal base class. That might mean something for Objective-C folks here. You don't have to import stuff. Like we said at the very beginning, types are inferred. And I think we really don't have to say that in 2015 or 2016 or whatever it is, but you know, here you go, automatic reference time. or 8. Properties and classes. You know, it's all stuff that you've seen. Methods, properties, and initializers. That's how you declare a property. So there's your inheritance. The cat inherits from animal. And there's your property. Okay, so description is a property, and each property allows you to override these specific blocks of code. I don't know, what would you call these things? So get and set, easy stuff. Maybe in Objective-C I used to use property overrides all the time, and so you can do other stuff in there. There's your scope, go crazy. Initializers and overriding. That's your initializer there. That's how you call stuff in the superclass. That's how you assign a variable. If you want to override something with a superclass, prefix it with override, variable, name, parameter list, and get in this case. These are interesting. Will set and did set. Like a will set and like a did set. In will set, this code block here runs, and you have access to the old value. So it's big. Mouth is big here. Did set is if I did something to it, and did set, the value here has the new value. Has anybody here used those? All right. How you know? Give us a real world example.
For example, if I have a variable holding a host name,
Alrighty.
in will set, probably I would use a method to validate. For example. Or yeah, it's basically observing.
So key value built into the language.
Awesome. You can make, for example, a log entry using this. If you change a value and you want to keep a log entry of the previous value and the second and the next value, you can use this to store a log entry in another table.
Nice. And these are how you do methods in a class. So everything we said about functions in the class. Nothing spectacular here. All right, error handling. To respond to error conditions you might encounter during execution. It has a nice analogy. If you read the book, it says if you use error handling, you get specific information about the cause of your error, whereas an optional, all you know is like something went wrong and you don't know what it is. Basically, the presence of a failure, like it says here. Throw keyword at the end of the function. Do, try, catch. Not a lot of people using these. Alrighty. So as I said, Swift, it's open source. There's Linux support at the moment. I'll be putting this slide at the comment of the meetup. If you go to Swift getting started, there's some tools about how to get up and running on Linux. If you're working iOS, you have Xcode, you can start a new playground, and much easier to get started. A very nice Ray Wenderlich tutorial there, how to get up and running with Swift on Linux, and obviously another Cocoa for Linux. And I found these nice repos. So the last one is a pretty cool style guide, how to work with them, and some pretty cool open source non-OS based repositories. This one's pretty interesting. It's pure Swift. He wrote a HTTP server for that. Have you ever come across these? That was really nice. Nice to to get up and running and get started. There we go. That's me. A couple of apps I've written there, and some social, Twitter and GitHub. Not a lot of crazy stuff on my GitHub. Some Android stuff, some Java stuff. A couple of components I haven't updated forever. I'm working on an image downloader that I might release to the world, but I always update it. So there it is. Are there any questions, or anybody want to start up a conversation about what we talked about here? No?
Can you explain a bit more what the unwrapping options do?
Force unwrap.
Yeah, I think
All right.
basically.
It provides access to the underlying value, forcing you.
I still don't get it.
The optional is like a drawer, and
Yeah.
you either have the drawer with something in it, or you have no drawer at all.
Perfect.
That's the simplest explanation.
Yeah.
That's a great
And
analogy.
you're
Yes.
trying to open the drawer and get something from it, but
Oh, so you
there's
can get the
no-
value.
nothing to grab.
So there's either a value. Yeah, so what is this here? There's a value and it equals x, or there's not a value at all. So here, it's a dictionary, and you're passing it a key, and you want to get its value. And the compiler is smart enough to know that there's a very strong possibility that there might not be a value in there. And it's an optional. If you remove that, it would refer as an optional. So since it's an optional, you can either check if it's nil or not and do something with it. If you're very sure that the value is included within that, you can just put the exclamation point at the back. You can force unwrap it. Yeah?
The plus from Objective-C is that if you declare a variable as an optional, while you write the code, it helps you check if, for example, if you have an HTTP request and you don't know if you receive the result from the server, it helps you to know if it has a value in it, and you can force unwrap it if you are sure, if the developer is sure that there is a value in there.
Like, if you had Force Awakens Vader equals 5, one line here, so you know it has a value, you'd be able to force unwrap it because you know. If any other situations where you know what it is?
No, but
So it really checks what the variable is defined.
No? Well, we have one good explanation, one not so good explanation. Anybody else want
You declare that this variable will be null from this.
okay, I'd like to go back to the drawer analogy because it was
Yeah,
a
it's
great
pretty
one.
good.
So the optional says I'm a drawer, okay? I'm an optional. If I have something in my drawer, you can get it. But if there's not something in the drawer, your program will crash.
If there's not something in the drawing, you try to get it.
Yeah,
the program
yeah.
crashes.
So the exclamation mark essentially says,
Make sure
I don't
there's
give a
some-
fuck, I will open the fucking drawer and get whatever it is, right?
And there's nothing in there.
Right, yeah.
Yeah.
But you're not supposed to do this. This is like, this is pretty safe. You see this all over the place. So here's like, this is Swift syntax. You check if a nil, do something or do nothing else. Since you know there's a value, you can definitely put the exclamation mark and assign it to that. Here, if I use Vader inside, I don't need the
You don't
exclamation
need
mark. I can use it right away because it's taken care of with, they call this optional binding.
And the fun stuff is that if you want to print an optional without unwrapping it, you will actually print the drawer as well. So it will be optional parentheses value of the optional parentheses.
the bells and whistles you have private, protected, and public. Public can use by everybody, protected by your subclasses, and private only within.
By default,
No, the
By
default.
default, they're protected, I think.
By default, they're internal, which means they're essentially public, but only within the same module.
What are you guys working on at the moment? Pure Swift. You work for. You don't have to answer. I just want to get the
It's
ball.
just a casual game.
All right, casual game. Is it going to be on the App Store at some point? Yeah. Ah, you're working on this together. Okay, cool. All right.
I'm working on an app to measure distances. By putting the phone somewhere, press start, move it here, press stop, and it should say how much it has moved. But I have issues with the noise.
Okay. Obviously, you're not using location because GPS has a
No.
10-meter resolution. Is it trade secret? Can you?
Accelerometer and gyroscope.
Oh, okay. And how accurate?
Very inaccurate. If the phone just stays in the same place for 10 seconds, it says it moved between 10 centimeters and 1 meter and a half.
Okay.
Which device?
Hmm?
Which device? It's
An iPhone 5 from 3 years ago. 3 years old. I don't know how much they improved the sensors.
Check the Swiss knife app, I think. It actually measures distances. You use both with, let's say you give it here with the height you're holding your phone, and then you're aiming with the top line in one spot, and you tap, then you spot the other one, you tap again, and it measures through the gyroscope and the angle. I think it's called Swiss knife.
I want to ask something that was not in the presentation about initializers and inheritance. The two types of initializers. Can you explain? Because I'm a noob and I didn't get it at all, and I was using SpriteKit and I found some example and just copied.
All right. Well, I'm a noob too. Who wants to pick it up on it? Anybody interested in it?
it's in Swift.
I'm looking at thumbs.
Okay.
But what's the? Are you confused about the designated, the convenience?
Yes, both.
Yeah. What about it? You need to be more specific.
How do you actually use them? How do you understand what is convenience and designated? By documentation only?
No. So convenience initializer is like an alias. Like you have an alias in yourself. So you say maybe the default initializer action is init view with baron A, another argument B, and another view controller C, and another something D. But this is too cumbersome, right? So you create a convenience initializer that is just init, and the convenience initializer actually calls the original initializer with the default values.
So,
Do you get it?
yes, so actually that's why you are not allowed to use the parent classes
The designated.
designated initializer.
Yes.
Okay.
More or less.
All right then. Let's take a couple minute break and
Thanks.
thank you.